Let us solve this differential equation. Cot or cotangent x dy by dx plus y is equal to cosine x. Now, direct integration wouldn't work, and if you try separating the variables, that wouldn't work either. But let's see something here. Suppose you divide both sides by cotangent x. You would get dy by dx plus 1 divided by cotan x, y equals cos x over cotan x. I keep writing cos t, it's cot x. Alright. Now you see that it is in a certain form. It's in the form dy by dx plus py equal q. Alright. And when it is in this form, you can use the integrating factor method. Alright. So what is the integrating factor? It is e to the integral of p dx. What is p? P is this. It's what multiplies y. So what we have is e, the integrating factor is e to the integral of 1 over cot x dx, 1 over cotan x dx. Alright. Now, let's integrate 1 over cotangent x. Let's find the integral of 1 over cot x dx. Now, if you look in your table of integrals, you don't really have a table of integral. If you look here in your table of derivatives, you don't see anything that's differentiated and give you cotan x. So what do we do here? Well, cotan is 1 over tan. So it's the integral of 1 over tan x dx. But 1 divided by 1 over tan is really tan. So the integral of tan x dx. But again, if you look in your table of derivatives, you will not find anything that you differentiate to get tan, so that you can integrate tan to get back that thing. But let's see something here. Now, due to having to integrate tan, you will do a lot more work than just solving, or within solving the differential equation. Hopefully in exam you won't get a problem that is as complicated as this, right? But you get one that's more straightforward. But here now, tan. Is there another way to write tan? Of course, it is sine x divided by cosine x. You have to remember your trigonometric identities, and this is one of the basic ones. Tan x is sine x over cos x. Now, in this case, to integrate this, you'd have to use integration by substitution. So let's try that. Let u be equal to cosine x. So when you look at this, you see that you're integrating, what you're integrating is f prime x over f of x dx. So that whatever is in the denominator, you can differentiate it to get what is in the numerator. Alright? So you make the substitution be equal to the denominator function. So let's go with this one. U is equal to cosine x. So the u by dx equals, well, in in this case, when you differentiate sine, you get cosine. So when you integrate cosine, you get sine. Alright? So here, remember, if you look at your table of derivatives, when you differentiate sine, you get cosine. So when you integrate cosine, you get back sine. Alright? So du by dx is sine x. So here now, what is dx? Let's transpose for dx because we have a dx here. Let's transpose for dx. Dx is equal to, it would be, well, it would be du divided by sine x. Alright, so that's what we get. So what we have is the integral of sine x over cos x dx. But we said that u is equal to cosine x. So we can remove this cosine x and put u there instead. And then dx, but dx is du over sine x. So let's remove this dx and put du over sine x there instead. Alright, we cancel out. So what we have is the integral of 1 over u du. And when you do that, we have ln u plus c. Now, u is cos x. So what we really have is ln cos x plus c. Alright, so let's see this now. E to the integral of p dx is e to the integral of 1 over cot x dx is e to the integral of sine x over cos x. And when we find the integral of sine over cos, we get this. So our integrating factor then turns out to be e to the integral of that dx, which is ln cos x plus c. But we won't use a plus c in this case. Right? Remember, c can be any variable. Let's use 0 for c. So we have e to the ln cos x. Now, here, let's get back to it. We're going to multiply both sides by e to the ln cos x. But the thing is, you can simplify the integrating factor even more. When you have e to the ln of something, you're just left with that something. It's like e and ln cancel. Alright? So this turns out to be cosine x. So we multiply both sides by cos x. What we have is dy by dx. We had dy by dx plus 1 over cotan x times y plus 1 over cotan x times y equals cos over tan, no, over cot, cos over cot. So we have cos x over cot x. Alright. Now we multiply both sides by the integrating factor cos x. So times cos x, this times cos x, and this times cos x. Now we have a cot here, but remember, cot is 1 over tan. So we have 1 over 1 over tan, but this turned out to be tan. So tan x, but tan is sine over cos. So this was sine x over cos x. Alright, we fix this part up. Let's look at this. Cot is 1 over tan x, but 1 over tan x is 1 over sine x over cos x, but 1 over sine x over cos x is cos x over sine x. So this become cos x over sine x. Now, here, if we have all of this divided by, remember, this was cos over cot, and we multiply by cos. That's how we get this. If we have all of this divided by cos over sine, it's like we're multiplying by sine over cos. So let's say this times sine x over cos x. And what happened? One of the cos x cancel this. Alright, so we have cos x sine x. So what we have here now is dy by dx times cos x plus cos cancel cos. So we have sine x times y. Let's say y sine x equal. Then we have, let's put the sign first, sine x cos x. Alright, so there we go. That's what we have. Alright, now here we integrate both sides now. So we have the integral of, oh, by the way, hold on. What am I saying? We see that what we have here is a product rule, you know. Here, you hold y and differentiate cos. Oh, if you differentiate cos, you get negative sine. And if you hold y, when you differentiate cos, you get minus sine. And here, when you have cos, and you hold cos and differentiate y, you get dy by dx. Alright, so here now, what we have, when we said we differentiated cos, oh, sine cos, when you differentiate u cos, we get sine. Good. Sine cos, cos sine. If you differentiate sine, you get cos. When you integrate, when you differentiate sine, you get cos. When you differentiate cos, you get negative sine. Oh, I made a mistake here. When you differentiate cosine x, you get negative sine x. So this should have been negative. So negative. Alright. So there should be a negative in front of there. So dx is negative. Right? So when we found dx as this, there should have been a negative here. So all of this should have negative. So there's a negative here. Negative. There should be a negative. Alright. So this is a negative cos. Right? So this should have been a negative. Negative. Alright. So here my mistake was differentiating cos and getting sine. When you differentiate cos, you get negative sine. So differentiate, you get negative here. Dy dx is negative. Here, when you substitute and make du over, it should be negative. Initially, the negative would have been here because you have a negative, right? But negative eventually come up here. So it's negative 1 over u du. So it's negative ln u plus c. So e to the negative ln cos x would be negative cos x. Alright? This would be like saying e to the ln of negative cos x. So it would be negative cos x. So you should have a negative here. So it would be a d by dx of negative cos. Alright, so that was my mistake. Alright, it's negative. Now, here, I notice that this is really the result of differentiation, differentiation using the product rule. You hold y, differentiate cos. You differentiate negative cos. When you differentiate negative cos, you get positive sine. Right? You differentiate sine, you get negative. When you differentiate sine, when you differentiate sine, you get cos. But when you differentiate cos, you get sine. So you differentiate negative cos. When you differentiate positive cosine, you get negative sine. So when you differentiate negative cosine, you get positive sine. So this sine is a derivative of negative cos. Now here, you diff, you differentiate y to get dy by dx, and you hold negative cos. So what you have here then is a product rule from differentiating y times negative cos x. Right? So that's what happened. You find the d by dx of y times negative cos x. Right? It's a product rule. And this always happens on the left hand side when you are using the integrating factor method. You have to look out to see what it is, what product this is that you differentiate to get this. Alright, equal sine x cos x. Now, integrate both sides. The integral of d by dx of y times negative cos x equal the integral of sine x cos x dx. Alright. I've run out of scrolling space, so I'm going to have to draw a line up and continue on the right hand side of this line. So let's do that. Alright. So what we have here then, the integral of d by dx of anything is like the integral and the d by dx cancel each other. So what we have is y times negative cos x equal. So we have y times negative cos x equal, and then on the right hand side we have the integral of sine x cos x dx. So we have the integral of sine x cos x dx. Alright. Now here we're going to have to use integration by substitution again. Alright. So you see the reason why I said I hope you don't get an exam with this type of question. Complicated. You have to use integration by substitution twice. And here I would give a take-home assignment, a graded homework, but not in a test. But anyway, here let u be equal to, let me see now, which one? So when you differentiate sine, you get cos. So let u be equal to sine x this time, so that the u by dx is equal to cos x, and then dx is equal to the u over cos x. Now, this is the integral of sine x cos x dx, but we have u is equal to sine x, so this is u, the sine x is u. What about the dx? Dx is equal to du over cos x, so this dx, let's put du over cos x there instead. Du over cos x. So notice what happens here now. Cos x cancels cos x. So the integral of u, du is what we have, which is u squared over 2 plus c. Alright. Now, y times negative cos x, y by negative cos x is equal to, now when you integrate the right hand side, you get u squared over 2 plus c. U squared over 2 plus c. But what was u again? U was sine x. So it is sine squared x. Alright? Over 2 plus c. Alright. Now, here, what we have is y is equal to, let's divide by negative cos sine squared x over negative 2 cos x plus c over negative cos x. But since we have negative and positive here, like you're minusing c over cos x. So here y is equal to, well, this is the answer, you know, but let's see if we can neat it up a bit. You could even leave it as y times negative cos x equal sine squared x over 2 plus c, right? But that might be considered as incomplete if you don't write it as y equal. So write it as y equal. You could leave it like this, but let's see something here. Suppose you say this is sine x times sine x over cos x, and this over negative 2 minus c over cos x. What you could do here is say y equals sine over cos is tan. Tan x, so it's negative half tan x sine x minus c over cos x. Alright? I guess that could work as a solution. Alright? So that's one way to put it. Well, another way, because you could very well leave it as negative half sine squared x over cos x minus c over cos x. But anyway, you get the idea. But let's say this was a question with requiring a lot of work, right? But we're going to be looking at other examples in our next set of videos. So I will see you then.